Dear learner, I am Dr. Biswajit Manti, Associate Professor, Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. In our previous lecture video, I finished Huffman Shannon Fano coding. So, number one Shannon Fano we have completed. So today discussion topic is Huffman coding. So this is finished. Now today we are going to solve this. So we'll take the same numerical which was performed for Shannon Fano coding. So we'll take here the same problem, that is, so problem number 1, x, the messages are given x1, x2, x3, x4, x5, x6, x7, corresponding probabilities are given. Those are 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, 0.04. So these are the messages x1, x2, x3, x4, x5, x6, x7, and corresponding probabilities are given. So now how we will solve the problem, that is most important. So here what we will do is that we will make a table. First one, message, then probability, then first reduction, second reduction, third reduction, fourth reduction, fifth reduction, in this way. So what are the probability? High to low, 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, and last one is 0.04. So we should write the corresponding messages. So this is x1, this is x2, this is x3, this is x4, x5, x6, and x7. Now what we will do that? It's a very simple process. We will start from the bottom. That is, we make a pair, we make a group of two probability, two messages. So like the last one, from the last. So from last, what is this? This is these two. So if we add together, what will happen? It will be 0.12. If we add together, so 0.08, 0.04, if we add, it will be 0.12. So in the next column, we will add in the corresponding position. So let us, in the first reduction, it will be 0.4, it is 0.2, 0.12, 0.08, 0.08. Now what we will do, this is 0.12. So now if we add together, we are getting 0.12. So we will put it here. It will go like this here. So 0.12. This is 0.12. Now in the next reductions, and we will give it as this is 1 and this is 0. So 0.08 now coded as 1, 0.04 coded as 0. Now we will take again these together, this 0.08 and this 0.08 together, and it will give this is 1 and this is 0, and if we add together it will be 0.16. So it will be 0.16. So now see, this is 0.4, 0.2, 0.12, okay, and this 0.12. So now we just make a clear it. This one, because no space is there. Second reduction, third reduction, fourth reduction, and fifth reduction. So now in the second reduction I am again doing. So this is 0.4, 0.2, 0.12, this 0.12. Now we will add together these two, and it is 0.16. So 0.08, 0.08, if we add it will be 0.16. So where 0.1 here 0.16, this position should be 0.16. So this position should be 0.16, and it will go like this, like this. So this is 1 and this is 0. This is 1, this is 0. 0.16. Now again we will add last two, that is in the for the third reduction, these two together, this is 1 and this is 0. So if 0.12 and 0.12, if we add, how much it will be? So 0.12, 0.12, so it should be 0.24. So 0.24 we will place here. So 0.4, 0.2, 0.16, okay, 0.16. Now if we add together it will be 0.24. So 0.24 means it should be below to the 0.4. So 0.24. So it is goes to this position, 0.24. So now again we will add these two. So it will be 0.36. It will be 0.36. So that means 0.4. This will go to this place, 0.36. Then this 0.24 is there. This is 1 and this is 0. Now again, if we add together, this is 1 and 0, it will be 6. So 6 means I will write fifth little bit top, fifth. So 6 means it will go to the top, 0.6, and this is 0.4. So again these two point. So I am writing here because of no space, the fifth column I am showing here, fifth column. So what is fourth column? Fourth column is there, 0.4, 0.36, 0.24. So we are adding together. So this is 1 and this is 0. So it will go to the fifth column. So if we add together it will be 0.6, and this 0.4 is there. So again these two should be 1 and 0. So that's why this 0.6 is 1 and 0.4 is 0. So we make a small to make you understand. Please try to understand because space limitation came here. So So if we add together, it will be 0.6 and this is 0.4 as it is. So again it will be 1 and 0. And this is also 0.061, 0.36 is 1, 0.24 is 0. Okay, so now we got, so that I have shown here, that I was shown here, so no need, I have shown there only. So now what is our target? This is the tabular form reduction up to fifth reduction. Okay, now I am showing you one. I will not show you all the codes for all the messages. I will show you here one. So suppose I am telling for C1, C2, C2. I am telling for X4. Suppose I am telling for X4. This X4. What should be the bit for X4? So X4 is 0.08. Listen carefully now. X4 is the message and its probability is 0.08. So this is the case. Now, so 0.08 where this is 0.08. Now this is 0.08 where the code start. So 0.08 starts with 1. So we will write 1. Then 0.8 added, it goes to 0.16. What is the 0.16 code? 0 here. So 0.16 here is 0. Now this 0.2 and this 0.2 and 0.16 we are adding and we are getting 0.36. This 0.36 we are getting and that code is 1. So that code is 1. And 0.36 and 0.24 if we add, it will give you 0.6 and that code is 1. So this side, the last side, fifth reduction should be MSB, and that way you have to come. So that means this one is MSB and this is LSB. So we should write this way. This is 1, this is 1, this is 0 and this is 1. Because this is LSB, LSB is this side, MSB should be in the left side. So 1101. So 1101 for X4. So for X4 code is C4 and the code C4 is equal to 1104 and code length, how much? Code length is 4. How many bits are there? 1, 2, 3, 4. So 4. So this way we have to solve we have to find out all the codes. Okay. So now I am copying the page and I am pasting here. And I will clear it. So this is the case. I can delete this one. So now I will show you the code C1, C2, C3, C4, C5, C6, C7. So C1 means for 0.4. So 0.4 starts, 0.4 start, 0.4 start, 0.4 start, 0.4 start, 0.4 start, 0.4 start. So 0.4 and the last we are getting 0. So C1 is equal to 0 and length is 1. Now C2 is how much? C2 is 0.2. So 0.2, 0.2, 0.2. Here 0.2 we are getting 0.2, then its code is 1. So this 0.2 code is 1. So code is first, I will write here 1. So 0.2 is 1. This 0.2 and 0.16 again contribute 0.36. For that is also code is 1. And 0.36 and 0.24 code is 0.61. So 1. So all are 1. This side is MSB, this side is LSB. So 1, 1, 1, 1. It should be 1, 1, 1. So number length should be 3. My dear student, please try to we have a look here. This is most interesting and important. How do we are getting the code for this particular messages? So this is most important. How we are getting the code. So you please remember, my dear students, the from fifth reduction should be the MSB, and the in that way you have to come fourth reduction, third reduction, second reduction, and first reduction. So minimum reduction, the first reduction should be the LSB. So right side is the MSB. That is the fifth reduction is the MSB. Now C3. C3, I will change the color here. I will make it some red color. So X3 means C3. X3. So 0.12, 0.12. Now 0.12 here we are getting 1. Okay. So we are getting 1. So starting bit is 0.12. You write here, otherwise later you forget. 1. So 0.12 and 0.12, how much? 0.24. 0.24 is here. But code is 0.24 is code is 0. So 0. Now 0.24 and 0.36, if I add together, it will give 0.6. Then code is 1. So 1. So now this is MSB. And this is LSB. This one. So 101. So that should be 101 and the length is 3. Okay, now we'll go for, my dear students, we'll go for X4. X4 already, X3. So C3. Now X4. X4 already I mentioned. What we get is that X4. I here show here. X4 means C4 is 1104. Already we have calculated. So I am not again repeating. So X4 is C4 1104. 1101. 1101. So X4 is equal to C4. Is 1101. Again here the number of bit is 4. Now dear students, will go for 5. Please try to understand. If you have any doubt, you please comment a comment in the comment box. And if you have any doubt, you please, whatever you have the doubt, you can write there. I will address all those issues. So X5 means 0.408. So 0.08 start here. 0.08 means 0. So it starts with 0. 0.08, 0.08 here we add together. So it will be 0.16. But 0.16 code is 0. Here 0. So again 0. And 0.2 and 0.16 if we get 0.36, and that value is 1. The code is 1. And 0.36 and 0.24 if we add together, it will give 0.6 and the code is 1. So 1. Now what I told you earlier, my dear student, the fifth reduction, that is the rightmost, should be the MSB. So that means the number should be here 1100. This is not 0011 because it's wrong. This is LSB side. This is LSB. This 0 is LSB. This 1 is MSB. So MSB should be first. So 1101. Again this is 4. Length is 4. So 1100. Now C6, my dear students, C6, X6. So 0.08. So for 0.08, what should be the code? 1 is there. So we will start with 1. Please see how I am writing. It's most important for the exam. So 0.08, the code is 1 here. So for 0.08, we start with 1. So 1. Now this 0.8 and 0.08 and 0.04, if we add, it will give 0.12. And 0.12 code is how much? 0. So 0. Now 0.12 and 0.12 together adding, it will goes to 0.24, and 0.24 code is 0 again. Now 0.24 is 0, so I wrote 0. Now 0.24 also going to 0.6, contribute 0.6. So 0.36 and 0.24 together added, and we are getting 0.6, and 0.6 is nothing but 1. So 1. So this is MSB side, this is LSB side. So it should be 1001. Again the code length is 4. Now dear students, we'll go finalize. We'll finalize. What will finalize? The last code, that is the X7. So what is X7? 0.04. So for starting is 0. So starting is 0. Now it contributes to 0.12 because it goes to this way up to this. So 0.12 and 0.12 code is 0 here. So this is 0. Now 0.12, 0.24. So 0.24 code is 0 here. So again 0, and 0.24, 0.36 contribute 0.6. And 0.6 is 1 because 0.6 is 1. So this is 1. So ultimately we are getting what? This is MSB. and this is LSB, dear student. So it should be 1 0 0 0, not 0 0 1. It should be 1 0 0, that is 8. So this, in that way we are getting all the codes and the code length. So once we get the code length, it's now we have everything in our hand. So we got messages, we got probability, we got code, and we got code length. Okay, so we can arrange nicely here message probability pi or pk, code word, and code length. So x1, x2, x3, x4, x5, x6, x7. What is the probability? It is 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, 0.04. Now, what are the code we got? C1 we told 0. C2 is equal to, we got 111, because we know that 111. Then C3 we got 100. C4 we get 1101. C5 we get 1100. C6 we get 101. C7 we get 1000. So now what is the code length? Code length for this is 1, for this is 3, for this is 3, for this is 4, for this is 4, this is 4, and this is 4. So this is the final table we got. Is the final table, what we get is that. So now we will calculate. What we will calculate? the case. So this is the final result. So together I am writing here L bar Hx efficiency 1 minus efficiency. Okay, so L bar we get 2.48 letters per message, 2.42 bits per message. This is 97.6% and this is 2.4%. So these are very important. So maybe I this numerical. So this is all about our Huffman coding. Hope you people understand. You try to repeat the video if you don't understand and pause and try to solve this numerical. So I am giving you as home task one more numerical. Please do it by your own. Okay. If you don't get, in next video I will come with this one. So so that one I will give you. Okay. So or otherwise I will come with next video. The next video. So till then, before closing, I am giving you the numericals. One more numericals. Okay. So x is equal to x1, x2, x3, x4, x5, x6, x7, x8, and the probabilities are 1 by 4, 1 by 8, 1 by 16, 1 by 16, 1 by 16, 1 by 4, 1 by 16, 1 by 8. So using Huffman coding, solve the problem. So same here, you find out number 1, L bar, average code length. Number 2, the entropy Hx, entropy. Number 3, the efficiency eta, and 4 is the redundancy. There is nothing but 1 minus eta. So hope you people understood. So thank you for your concentrations and watching this video. If you like my channel, please subscribe and like all the videos. Thank you. Now for today's session I am closing. We will come with new exciting videos. Thank you so much.